take a very detailed look on slicing and counting the slices of our standard pizza. Well, first off, let's say it's just been sliced, it's in the box, and here it is. Well, we have 8 slices in 8 pieces, right? So it's 8 over 8, so we have one entire pizza, one whole pizza. So friend comes along and asks for a slice and takes this away. Well, now we have 7 out of the 8, right? All right, so then someone else comes up and then I come in here and I'm going to wolf down a couple of slices. So you're going to have, 6 and then 5 and then 4 and then 3 slices are going to be left over, and then you're going to have 2 slices left over, and then someone better hurry and get the leftover slices. So I'm going to grab that one, and then of course everyone battles for that very last slice, right? So whoever eats the fastest, right, gets that last slice, right? Yeah, so when you have 1 slice left, okay, you grab that. What do we have left over? Well, we have now 0 slices out of the original 8. See, that's what we have over here. So 0 over 8, or 0/8, well, it's just 0. We have no pizza left. And this brings about some more definitions. So let's take a look at some other stuff. If a is any number except 0, a divided by a equals 1, and 0 divided by a equals 0. A over a means any number except 0 divided by itself is 1. 0 over a means 0 parts of any number except 0 of original cuts is just 0. So the a over a rule can be seen right here. We have 8 divided by 8, the answer is 1. We had 8 slices out of 8, we had 1 whole pizza. And then we ate the whole pizza, so nothing's left. So 0 slices out of the original 8 is 0, is an example of the 0 over a, or any number rule. Now the a over a rule is also very important because later on we're going to need to be able to rewrite the number 1, change its form for our convenience. So there may be an instance where instead of 1, I'd like to have something that looks like 8 over 8, for instance, or how about 2 over 2, or 3 divided by 3. So having this rule is going to be very important and very handy very soon. We have like fractions when 2 or more fractions have the same denominator. This matching denominator is the common denominator. Are these like fractions? Well, look at the denominators. They're all the same. So since they have the same denominator, they're like fractions. And again, you can say this is a common denominator of 8. I want you to look very carefully at this scenario. So here now we have 4 different slices. But how much really of the entire pizza do we have left? So we have 4 out of 8, but really this is just half a pizza. So 4/8 is really the same as 1/2. Something to think about. Hey, what if, okay, again, someone come by and whip down a couple of slices right there. So now you have 2 out of the 8 slices. But look at this. This is, compare it with this thing. See, this is a quarter of the pizza left over. So that is 1/4. Really? So let's now try to generalize and talk more about this. Equivalent fractions are fractions that are different in form but have the same value. We will use an equal sign to mean equivalent fractions. So now we can say that 4/8 is equivalent to 1/2, and we can say 2/8 is equivalent to 1/4. What common fraction or fractions can you see here that's being represented by these stars? Well, out of a group of 6, 1, 2, 3 of them are a different color. So that's an answer. I can say 3 out of the 6 stars is a common fraction. But looking at this again, wait a minute. Half the stars are blue, half the stars are gray. So I can just say 1/2 is also a common fraction. But we just talked about the same group of stars. Therefore, we can say 3/6 is equivalent to 1/2. Something to think about. Now we saw earlier that 4/8 is equivalent to 1/2. And we just saw in our previous example that 3/6 is also equivalent to 1/2. So they're all equivalent to 1/2. In fact, there's an infinite number of equivalent numbers to 1/2. You could have something like 1,234 divided by 2,468, and that is really 1/2. Now, if you put this on a test, I mean, it's correct, but it would really annoy your teacher. So, one of the things we want to do is try to make the numbers as small as possible, as low in value as we can, but still mean the same thing. This really does mean the same as 1/2, but this is easier on the eyes than that. So all this that we're talking about brings us to our next definition. A reduced fraction is a fraction that is in its simplest form. 4/8 and 3/6 are not reduced fractions because there exists something else that is in a lower form. Well, how can we be sure something is in a reduced form? How can we change maybe something like this or like this into something like this? So let's do that next. Now I want to find a method that would automatically and systematically reduce 4/8 into its reduced form, 1/2. Well, looking at the 4 and I wanted to get a 1, what can I do to 4 to get 1? Oh, I can divide by 4. 4 divided by 4 is 1. Oh, okay, so let's try that. I'm going to divide this by 4. Yeah, the answer is 1. But anything you do on the top of a fraction, you better do on the same thing on the bottom of the fraction. So I need to divide this by 4. Would that give us what we want to? Yeah, 8 divided by 4 is 2. Would that work with the 3/6? Let's try that. So if I have 3/6 and I want this to be 1/2, what can I divide 3 by? Well, 3 divided by 3 is 1. 6 divided by 3 is 2. So that seems to work. The procedure we just did doesn't work for addition or subtraction. Okay, you can only divide or multiply numbers in the numerator and denominators by the same numbers to get a reduced fraction. Let's see that with our previous example. Of course, you might ask, well, why just divide? Maybe we could do something else. There are other ways of getting a 1 from a 4, like subtracting 3. So if I have 4 and I go minus 3, let's extend that, the answer is 1. And 8 minus 3 is 2, right? No, we don't get our half right there. Oh, so this rule is not going to work. See, we get ourselves a 5. So subtracting, or even adding for that matter, doesn't work. A fraction is in lowest terms, or simplest form, if there are no factors in common, other than 1, between the denominator and the numerator. Now a mixed number isn't in lowest terms unless the fractional part is in lowest terms. So this mixed number, 3 and 2/4, is not in lowest form. But this one is 3 and 1/2. The cancellation method. Start canceling common factors, mentally dividing the numerator and denominator by the same number. Repeat this until you cannot do so anymore. I want to simplify this fraction right here. So first off the bat, notice that everything's even. So I can actually divide through by 2. So I'm going to extend this and go divided by 2, divided by 2. And what do I get as an answer? Well, I'm going to get 12/15. Now, have I simplified completely? Well, no, I can still divide things that are common to both. And I notice that there is a 3 in 12 and there's a 3 in 15. So I can divide the top by 3 and the bottom by 3, and I'm going to get 4/5. Now, can we reduce 4/5 any more, any smaller? Well, other than 1, now nothing divides into both. So we've successfully reduced this fraction into the lowest terms possible. Now we had to do quite a bit of writing here. Divide by 2, divide by 2, divide by 3, divide by 3. Let's now do the same problem over again, but in a much slicker and faster way. So here we have our 24/30. Let's cancel common terms top and bottom. So like before, we noticed there was a 2 in each, so I'm going to cancel the 24 and make that 12. Cancel the 30, make that 15. And I can continue canceling. There's a 3 in each, so 12 divided by 3 is 4. 15 divided by 3 is 5. See, that's going to be my answer. So I'm going to write down 4/5. And that is my final answer for this. And this is what's called the cancellation method. Now there's an even easier way of doing this. Before we divide it by 2, then we divide it by 3. Let's combine that. We can divide by 6. So 24 divided by 6 is 4. 30 divided by 6 is 5. And that's going to give us our answer. We're going to have 4/5. You see that? So trying to find the greatest factor that's in common is a very fast way of canceling this fraction and having it reduced to lowest terms. And notice what I said, greatest common factor. Well, that comes into play for our next definition. The GCF method. To simplify a fraction, find the greatest common factor, or GCF, of the denominator and the numerator. Then divide the denominator and numerator by the GCF, or cancel the GCF out. By the way, the GCF is also known as the highest common factor or the greatest common divisor. Now, finding the GCF is something that I do in detail in lesson number 5. So if you're not sure how to do that, you need to go to that lesson. Okay, now I want to find the GCF of the 24/30. So here's my 24, here's my 30th. I'm going to use the factor tree technique. So I'm going to think of two numbers multiplied will give me 24. Oh, how about 4 times 6? 4 can be broken down into 2 times 2. 6 can be broken down into 2 times 3. All right? Now, what about 30? 30, how about, oh, I see a 3 and a 10 right away. And then the 10 can be broken down into 2 times 5. So now we want to look at, well, what do they have in common? Well, I see a 2 right here, and there's a 2 right there. And there's a 3 here, and there's a 3 there. So, aha, 2 times 3 is 6, and that is my GCF. And with that, I can go, okay, 24 divided by 6 is my 4. 30 divided by 6 is my 5. That gave me my 4/5. Again, I've already done this, but I want to be a little more formal in that I find the GCF, and it helps me reduce the fraction. And you might think, well, why go through all this trouble? Well, when a number is kind of big, it might be to your advantage. But you can always just cancel, like we did before. Find just anything that will work. And if you can do that, you'll eventually reduce it. But it may just take a little bit longer, but it can always be done. For example 5, I would like to reduce this fraction to lowest terms. Now, okay, what method? Cancellation, GCF? Well, it's your call. Try both methods if you like. I'm going to try to be as straightforward as possible. Okay, when I see something like this, first I've noticed it ends with 5s. That means I can divide everything by 5. And you can use a calculator or by hand. So 225, and I divide that by 5, I'm going to get 45 as an answer. 315, divide that by 5, I'm going to get 63. So let's say that's what I'm left with. So 45 63rds. Is that as far as we can go? Well, take more to think about it. 45 63. What if you add up the digits? 4 plus 5, 9. 6 plus 3 is 9. there's a rule that says if you add up the digits and you get an answer that's divisible by 9, then that original number is divisible by 9. So I can divide this by 9, and I want to get 5, and divide this by 9, I want to get 7. So I want to get a fraction of 5/7. Can we go even further with this? 5/7, no, that's as far as I can go. So we've reduced successfully our fraction. All graphing calculus can convert numbers into fractions and reduce them. On the text instrument calculators, all you need to do is look for the division key, seen here. Now when you press that key, it changes into a / on the screen, like this. Now to actually change a number into a fraction, you need what's called the convert to fraction function. Where is that? Well, you would press the math key and then press enter, and you get something that looks like this. Now let's go ahead and try this with an actual example. Reduce 225 3/115 to lowest terms. For our first step, we press the clear key right there. Now we're going to input our fraction. 225 divided by 315. There's our fraction. Now let's convert this to a reduced form. So just press your math key and then just enter and enter again. Here it is, 5/7. Now we've learned how to reduce a fraction, to write it in lowest terms. Well, what if I actually want the opposite? I want to actually change a half into something like this, into 4/8. 4/8 is considered a higher form of a half. A fraction is in a higher form when the denominator and numerator are multiplied by the same non-zero number. In this example, we're asked to find an equivalent fraction to 3/4 with this denominator. How do we do that? Very easy. First step, divide 36 by 4. So 36 divided by 4 is 9. So now you go 9 times 3 to get 27. That's it. That's all you got to do. Let's try another example. So for this fraction, I want to convert 5/11 into an equivalent fraction with this denominator. How do we do that? Well, we went through the steps earlier. I'm going to divide 110 by 11. If you do that, you get 10. Then you go 10 times 5 is 50. And that's all you have to do. It's almost like a circle here. I go this divide by that, get an answer, times it by this, and then that will give me this answer. So it's very straightforward. For exercise 8, we're asked what fractions are represented by, well, this. Well, your first step is to figure out, well, how many total slices are there? So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's a total of 16 slices. So that's going to be my denominator. So I'm going to write down 16. Now, how many of them are shaded? So I have 1, 2, 3, 4. So 4. So that's an answer. But is that the only fraction? No, we can reduce this. So this is the same thing as divide by 2. I can get 2/8. And hey, why stop there? Divide by 2 again. I get 1/4. So there's my answer. For exercise number 9, I'm going to place this minute hand someplace on the face of this clock. I want you to draw it on your paper, and then I'm going to be asking you questions to convert fractions into its lowest form. So let's go ahead and try this. So let's say I'm going to start right here, and 60 entire minutes have occurred. So I want you to write down a fraction for that, for 60 minutes from 60 minutes. Well, that's easy. You just write down 60 over 60, and then the reduced fraction. Well, whenever you have the same number over itself, there was a rule we memorized for that. The answer is just 1, which of course makes sense because if 60 minutes have occurred, 1 hour passed. Now let's move our minute hand to right here. 50. Give me the fraction and its reduced form. Well, write down 50 over 60. A very fast way to reduce is to just cut out the zeros. So I'm left with 5, 6 as the final answer. Now let's change the minute hand from here to right there. I want you to create the original fraction and then the lowest form. Well, 45 minutes have passed, so now we have 45 over 60 equals. Now we can start dividing these numbers by 5s or maybe 3s, but there's actually another way of thinking about this. How much of an hour has passed? 3/4 of an hour, right? So that's a pretty slick way of finding the answer. And try to think of that. Sometimes maybe we want the hour version versus the minute, but I still want you to write down the minutes with 60 first and then reduce. There's our answer. Now let's try another one. Let's move our minute hand right there. Give me the original fraction and its lowest form. Well, we have 30 minutes have passed out of 60. But again, if you want to be slick about this, it is half an hour has passed. So, half an hour. Right, so now let's move our minute hand right there. Well, it looks like we have 25 minutes out of 60. And I want to reduce that. I don't have a slick way of doing that, so let's just do some old-fashioned mathematics. There's a 5 in each. 25 divided by 5 is 5. 60 divided by 5 is 12. So that's going to be our answer. Now let's go to right there. Well, it looks like 20 minutes have passed, so I'll write that down. 20 out of 60. And there's lots of ways you can see this. You can say, well, this is just 1/3 of an hour has passed. Or you can just do this by some canceling. There's a 10 in each. This is just 2 6. Cut these in half, you get 1/3. So there's my 1/3. Well, big guess where we need to go next, right? We're going to go right there. Give it a try. Well, 15 minutes have passed, so it's going to be 15 out of 60. And no big surprise, this is a 1/4 past the hour, right? So it's just a 1/4. Now let's go right there. Well, 10 minutes have passed out of 60 total minutes. I can cancel my 10s. I'm left with 1/6 of an hour. Okay, let's move this to right there. Now just a mere 5 minutes have passed in time out of a total of 60 minutes. 5 divided by 5 is 1. 60 divided by 5, we found out earlier, was 12. And again, that makes sense. There's 1, 2, see this, we have 12 numbers here. I'm on the first one, so it's 1/12 of an hour. Yep, I'm going to move this one more time. I'm going to move this to just a couple of tick marks right there. So just 2 of these. Give me the fraction and its lowest form. Well, if 2 minutes have passed out of 60, can that be reduced? Well, they're both even, so I can just divide by 2. 2 divided by 2 is 1. 60 divided by 2 is 30. So 1/30th of an hour has passed. Exercise 10 is actually designed for students who have access to these type of slices of pizza, or perhaps these fraction circles. Now, the circles you may have can be different colors. They're not necessarily will be matching this exactly, because different companies make these types of products. So with that in mind, I want you to take a look at this graphic right here. All right, so I want you to try to use these types of fractions to create equivalent fractions to that graphic you just saw. And try to come up with as many as you can. Now for the answer, there's many different ways of doing that. I'm going to use the pizza, and I'm going to go from like the smallest denominator to the largest. So here I can actually use 3/4 to represent the same shaded region as you saw in the graphic. Using eighths, we have something that looks like this. We have 1, 2, 3, 4, 5, 6 slices out of the 8 for our next fraction. Now, if you're using your 12 slices, this is what you can do. You can make 9 out of the 12 slices would create the same shaded region as the graphic. That's probably as far as you can go with most of these fraction circles, but with the pizza, there's one more shape we can do. For our last way of combining these pizza slices is if now we have the slices are in 16ths, these little ones right here. You can have 12 out of the 16 would create the same shape as the graphic we saw earlier. Now, a quick note, if you are in a classroom or at home trying to do this with these pizza slices, you would need 2 of these boxes, 2 of these sets to have enough of these 16ths to do something like this, just to let you know. So to conclude, all the fractions we created are called equivalent fractions. For exercise 11, I want you to take some time to simplify all the fractions listed. Well, for the first one, I noticed there's a 5 in each, so I can divide by 5, I'm going to get 4, divide by 5, I'm going to get 9. So to reduce this, I'm going to get 4/9. Now for the next one, well, 17 is a prime number. So if this is going to reduce, there would need to be a 17 in the 51. So either by hand or using calculator, you're going to say 51 divided by 17, and it goes into it 3 times. So I can actually divide both of these by 17. I would have 1 left over, and I would have 3 left over here. So my answer is going to be, but wait, that's not quite the answer, right? It's very important to remember that if it's a negative, the negative stays. A lot of people lose that when they're trying to simplify these. Now for the next one here, 11 is a prime number, and 11 does not go into 14. So guess what? It's already reduced. All right, so this one's a little sneaky, but I had to throw that in. Here, what's the rule for reducing a mixed number? Well, the integer stays, and what you do is you want to reduce to 5/20. Well, both of them have 5 in them, so I can 5 divided by 5 is 1, 20 divided by 5 is 4. So this would give us 8 and 1/4. Now for this last one, again, there was a rule that said the number over itself is just 1. So that's really all you need to do with that. Now what is the rule of 0 divided by any number? Oh, that's not 0. The answer is 0. So that's all we need to do for this one. And here, 6 divided by 0, well, we're not allowed to divide by 0. So you would answer like this, undefined. That's important to do that. What about this last one here? Well, again, straight away I notice they end with 0, so I can just cross those out. I can cancel those. And they're both even. So think of this as 26 over 46. I can divide by 2. That will give me 13. I can divide this by 2. That will give me 23. And I really can't do anything with 13 and 23. So that's going to give me my final answer, 13 23rds. Exercise 12 wants us to change 3/5 into an equivalent fraction that is in 30ths. So my denominator is 30. I want you to give it a try first. Again, this is one of the easiest problems we can have with fractions. And again, remember that circular thing we did? We said, okay, 30 divided by 5 is 6, and go times 3. The answer is 18.